Learners Algebra, Mr. Lawrence here with your flipped lesson. Today is Wednesday, May 9th. Yes, I think it's the 9th. All right, I know some of you are having trouble with this graphing and you're having a hard time with it. You need a little more direction. The only thing I'm disappointed at, very few of you have come in for help. Yesterday I only had one kid after school. He was a pre-algebra student, and the day before I had a couple 7th graders who stayed for a short period of time. But only one 8th grader, Courtney Ozanich, who came in. If you're having trouble, you need to come in for help. Lexi Kilpain did come up for lunch on Tuesday, and so she got some help there. So, you know, I'm proud of the people that did that. If you're having trouble, you've got to get involved in your learning. Come see me for help, and I will help you. But if you just sit back and ride the year out, oh, bad things are going to happen. You guys have come too far, you're learning too much, and you're too smart to let yourself get a bad grade this quarter. Okay? Come see me for help. I want to help you. All right. So we're going to do two things today. We have to talk about something, domain and range, we've talked about in the past, but let's do a graph first so I can help you out. Let's say we have this equation right here. Y equal to, say, 1 over x minus 4. Let's go with x plus 4, but let's stick that in a quantity, and let's put a 2 there, and then let's add 1 to it. Okay? Now the first thing I'm going to do, step 1, is to find my asymptotes. All right, let me get a graph over here. Hold on one second. Okay, so I look at this original equation, and I see that x cannot equal negative 4. X is not allowed to equal negative 4, right? Is that right? Yeah. So that means my asymptote is going to occur where x is negative 4. It's going to be a vertical line here. Okay, I think most of you have that part down. I'll put that in first. Now, by the way, that vertical asymptote is going to help me pick my x values for my t-table, in case you don't realize that yet. Now, for some of the graphs we've done, our horizontal asymptote has been the x-axis. In this one, it won't. You know what it'll be? It'll be the line y equals 1. Where do you suppose I got the 1 from? It's added to the end of the fraction. Yeah. So my horizontal asymptote will occur at the line x equals 1. And that's kind of big and bulky. I'm going to make that a little bit thinner. There we go. Ooh, I like that. I wish that was the default. Maybe one Brendan Lovejoy can help me figure out anyway how to make that my default. I like that, where the asymptotes show, but they're not dominating the graph. Okay, there are my asymptotes. Now I'm ready to make my t-table. All right. I'm going to start with some x values to the right of the asymptote. All right, larger than the asymptote's value. Asymptote's at negative 4, so I'm going to plug negative 3 in. I'm going to do the math, get out a y value. Now, I'm going to plug in another number. Maybe I'll plug in 0. Okay, why 0? Because it's easy to work with. A lot of times I like to plug in 10. I'm going to shoot for the symmetry on here, and if I pick a number 10 units away from the asymptote on the right, I'm not going to really be able to pick one 10 units away on the left because the asymptote is shifted over so far. Okay, but it doesn't really matter. You don't have to go for the symmetry, but it's easier if I do. All right, now I'm going to pick a number in between negative 3 and negative 4, the asymptote. But I'm going to pick it really close to negative 4. So I'm going to pick like a negative 3.9. That would be a number very close to the asymptote, right? Okay, I'm going to do the math, get the first part of my graph. So let me see here. If I put 0 in, I'm going to get 0 plus 4 is 4, times 2 is 8, 1 over 8 is 1/8. So at 0, I'm going to be at 1/8. So I'm going to be pretty low, pretty close to the horizontal asymptote. Oh no, Mr. Lawrence, I made a mistake. I forgot to add 1 to it, didn't I? Because it's plus 1. So it's going to be 1 and 1/8. All right. Oh, I had it in the right place. I just didn't write the right value. Okay, so there it is. It's very close to the asymptote. Okay, now I'm going to put negative 3 in. I'm going to get negative 3 plus 4 is 1. 1 times 2 is 2. 1 over 2 is 1/2. Plus 1 is 1/2. All I'm doing is plugging the value in there and doing the math in my head. If you need to do it on paper, that's fine, but it's really not that difficult to do. All right, so it looks like 1/2 is going to be there. All right, now negative 3 and 9/10. Now I wrote a decimal, but I'm going to think about it as 9/10. If I get negative 3 and 9/10 plus 4, I'm going to have 1/10 left. 1/10 times 2 is going to be 2/10, or better said is 1/5. 1 over 1/5 is the same as 5. 5 plus 1 is 6. I'm going to get a 6 there. So when I go really close to the asymptote, just to the right of it, I'm going to be up at 6. 1, 2, 3, 4, 5, 6. And it's going to be right there. And then my curve is going to do something like that. And that puppy is going to take off in both directions. Okay, approaching vertical and approaching horizontal. Now, to get the other 3 points, to make this easy, I'm going to use my symmetry. All right, so I'm going to go X and Y, and I am going to plug in, well, this X value was 1 unit away to the right. I'm going to go 1 unit away to the left. I'm going to go with a negative 5. Now watch what happens when I plug negative 5 in. Negative 5 plus 4 is negative 1, times 2 is negative 2, 1 over negative 2 is negative 1/2. Negative 1/2 plus 1 is 1/2. Okay, so at negative 5, I'm going to be at 1/2, half a unit below the asymptote. Notice this point here was half a unit above the asymptote, wasn't it? Coincidence? I think not. Okay, then I picked 0, which was what? 1, 2, 3, 4 units away. Well, I'm going to go 4 units away in the other direction. So if that's a negative 4, 1, 2, 3, 4, I'm at negative 8. Negative 8. All right, if I put negative 8 in, negative 8 plus 4 is negative 4, times 2 is negative 8. 1 over negative 8, negative 1/8. Plus 1 will be 7/8. 7/8. All right, so at negative 8, I'll be at 7/8, getting pretty darn close to that asymptote. All right, now I picked negative 3 and 9/10. This time I'm going to pick negative 4 and 1/10. All right, and again, I wrote a decimal, but I'm going to do the fraction in my head. Negative 4 and 1/10 plus 4 is 1/10. It's actually negative 1/10. Times 2 is negative 2/10, or better said as negative 1/5. Which is negative 5. Negative 5 plus 1 is 4, I believe. Negative 4, excuse me. So when I go to negative 4 and 1/10, I drop down to negative 4. 1, 2, 0, 2, 3, 4. There we go. And it should look pretty close to being perfectly symmetrical. It is difficult to draw them by hand perfectly. Okay, oops, I don't like that because I want it to hug the x-axis. So it's going to do something like that, okay? And then it's going to shoot. All right, shoot vertical and horizontal. And that's it. What was that at? Negative 4, 1, 2, 3, 4. So right about there. And that's it. Okay. I'll tell you what, we're going to hold off talking about domain and range. I'll put that in the weekend video. Tomorrow you do have a quiz. And remember with the quiz, you need to know these 5 things. You need to know how to add rational expressions. All right, you may want to go back and rewatch the video. We need an LCD. We need to have all terms in the denominator accounted for. Right? I'll take care of that one. So I'm going to multiply this by what it's missing. And this one by what it's missing, because I want the common denominator so that I can go ahead and add my fractions. And again, you may want to go back and rewatch an old video. Okay, over x minus 3. All right. Quantities, right? My numerator becomes x minus 3. Over here, I get a plus x plus 2. That is over my LCD. I'm not going to waste my time foiling that out. And I'm going to get 2x minus 1 over the quantity of x minus 3 and x plus 2. And I'll state my restrictions when x cannot equal negative 2 or positive 3. Okay, so you're going to have to know how to add. You're going to have to know how to subtract. Let's say I have the problem 5 over x minus 2 over x plus 1. Actually, let me change that. Let me make that minus 3 right there. Okay, again, I need to get the common denominator. So I go looking for my LCD. I know I need a quantity of x minus 3 times the quantity of x plus 1. Right? I need to get the common denominator, so I multiply each fraction by that special form of 1. Right? Okay, so I'm going to distribute the 5, and I'm going to get 5x plus 5. My common denominator, I just don't want to write it twice. Now, am I going to distribute the 2? Some of you are thinking yes, and I think you're going to have a hard time. I'm going to distribute a negative 2, not a 2. All right, and then you see that changes my answer. And so I'm going to get a 3x plus an 11 over the quantity of x plus 1 times the quantity of x minus 3. And I know that x cannot equal negative 1 or positive 3. Okay. Now remember that sometimes you can simplify. Like if I had x plus 2 over the quantity of x squared minus 4 plus 1 over x. An easier way to do this problem would be to first factor this denominator into the quantity of x plus 2 times the quantity of x minus 2. And then my x plus 2's can cancel out, leaving a 1 in the numerator, and my problem becomes less complex. And so therefore my LCD becomes x times the quantity of x minus 2. All right, I need to multiply by an x minus 2, by an x minus 2. And then here I need to multiply by an x and by another x. My numerator becomes x plus x minus 2 over x times the quantity of x minus 2. And simplified, that's 2x minus 2 over x times x minus 2. And this is an okay answer. If you wanted to, you could pull out that 2, get an x minus 1. Okay. Nothing's going to simplify there, though. My restrictions are going to be x cannot equal 0, cannot equal 2, and I have to remember over here, this quantity I canceled out, x can't be negative 2 either. Remember, you want to use the factored form of the denominators before you simplify to get your restrictions. Okay, so the cleanest answer I could write, x minus 1 over x times quantity x minus 2, where x does not equal 0 or plus or minus 2. Okay, if you gave this answer before I factored out, it would be okay as long as nothing factors out. Okay, there's also going to be multiplication and division on the test, on the quiz. And because we're getting a little bit long, and you can always go back and watch old videos, I'm going to just do a division problem. Remember that for a division problem, you must do multiplying by the reciprocal. So first I'm going to go 2x squared minus 50 over x squared plus 10x plus 25. And then you're going to multiply by the reciprocal. All right. Now, oops. 4x minus 4 is what I want to write there. I don't know why that won't default back to my old pen. All right, 4x minus 4. Now, In multiplication, you can just go ahead and factor and start simplifying. But in division, you have to change it to multiplication and use the reciprocal. All right, so I'm going to factor this guy, and he's going to factor twice. First of all, there's going to be a GCF of 2. So he's 2 times the quantity of x squared minus 25. That is the difference of perfect squares, so the numerator of the left fraction is going to turn into this. The denominator of first fraction is a perfect square trinomial, and it'll factor like this. The numerator of the second fraction does not factor. The denominator of the second fraction, you pull out a GCF. Oh, did I make a mistake here? Yeah, this should be a 20, shouldn't it? And then when I pull that 4 out, I should get a minus 5 there. Sorry about that. Okay. Now I'm going to look 4 ways. I'm going to look here, 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 and here. And if I see any factors that are common, they will cancel out. And it doesn't matter where I start. For example, I could say this, and that'll cancel. And then I see this and that. Okay? I see this, and then I have a 2 and a 4. My answer ends up being 1/2. Now, of course, x cannot equal -5, +5, and I think that's it. I have to check this denominator. I have to check this denominator, and I also have to check that because that used to be in the denominator. But there it is. It's that simple. Okay? Now I do want to warn you, do not do this. A lot of you want to do this. X squared plus 16 over 2x squared plus 8. Okay? You cannot do this. This is incorrect. I'll do it in green because it's incorrect. You cannot say that that is 2. This is division. This 16 is attached to the x by addition. Division does not undo addition. And the 8 is attached to the 2x squared by addition. You can't do that. Okay? You cannot do that. Don't do this. Don't do it. All right. I think I'm going to cut the video short right there. I'll say good night to you. Good luck on your quiz tomorrow. And Mr. Lawrence signing off. Have a good night, everybody.